So I'm still trying to convince you why name tuples are better. And let's keep talking about a problem. Like here's a problem that I can state. I can create a state where player is 3 and cell is x. So I've still mixed up the values. And here I've done it in an extremely explicit way, but it's not impossible that you just simply type the wrong fields. Here I'm being kind of malicious. I'm trying to show you that yes, I can really break this. Even with naming the fields, I'm still giving the wrong data types because the cell should be an integer and the player should be a string. And so starting in Python 3.6, they added this module called typing, and it allows you to describe the data structures or variables with the kind of data that it should hold. So in the very beginning of the book, there's a little side note about how Python is a dynamically typed language. And so you can set something equal to a string, and then you can immediately change it to be an integer, and Python is cool with that. And there may be times in your code where you really want that flexibility, but I'd like to convince you that it's generally a bad thing, that if a variable starts out as a string, it should probably always be a string. So how can we describe that to Python so that we can get that kind of continuity and safety of using a variable so that we know when we try to use this string that it hasn't quietly been converted to an integer and therefore it's going to create an exception in our program. So we can import these descriptive terms from the typing module. So here, for instance, I want to import the idea of a list and a name tuple and an optional. So these are ways to describe things that are in Python. Now, Python itself recognizes these type hints that I'm going to show you, but it ignores them. So it's not going to use it at runtime to verify that your program is actually creating something that is a list of strings or is a Boolean. But you can use MyPy to inspect your program and make sure that you're using these types correctly. So the first thing that we're going to do is I'm going to import these that I need to describe a class. Now when I say in the intro that I really stay away from object-oriented programming. It's not my cup of tea. I programmed that way for many years. And just after a while, I felt like it really wasn't gaining me anything, and in fact, it was introducing a lot of artificial complexity to my programs. And I started really writing in a purely functional way. But one of the things that I was learning from the purely functional languages was, having these really complex record structures that allowed me to describe an idea. For instance, here, I want to describe the idea of a state that has a board and a player, whether or not we're quitting, whether or not it's a draw, if there is a winner, if there is an error, and I can describe these with the data types of Python. So I've already decided that my board should be a list of strings. And so I can describe this class is a way of describing what will be instantiated as an object, but that's as far as I'm going to go with the object itself. I'm really just using this object, this class, as a type, and it's based upon a name tuple, which means that it's essentially going to be a read-only object. And I'm going to show you, I still haven't convinced you why that's a good thing, but let's just stay focused on this. So I'm creating a class. I'm using the class keyword, and I'm using here state is how I'm going to instantiate it, which is what we saw earlier here with the way I was able to say state and then pass in the player and the cell. So here I'm saying state, and here in parentheses is what it's going to be derived from, so the base class. And this is where object-oriented programming can get rather complicated, because this sets up a chain of inheritance, and so if you're thinking about ideas that you understand in the world, like a human is a mammal, and so we share the same characteristics, as with all these other mammals like warm-bloodedness and live birth and hair. And so those are some of the things that we share with mammals, and then we can go further up and we can say that we're all animals, and on up the tree of life into more and more generic ideas. And so from the most base idea, like all living organisms share DNA, for instance, and we have cells or things like that. Those are ideas that are inherited all the way down through the tree, all the way into fish, even into plants and things like that. So when you're setting up these hierarchies of objects, they can get really, really complicated, and you can start to inherit traits from different kinds of objects, and I just think that it gets really hairy really quickly. Here I'm going to make it very, very simple. I've got a state object, and it's going to be derived from a named tuple. And a named tuple is a data structure that we've already seen, that we've studied a bit now. It is a tuple that allows us to name the fields so that we can get access to them with names rather than positions. And so that's it. That's the depth of our object. We're describing basically a tuple that has 6 slots, and we're going to get at those slots by these names: board, player, quit, draw, error, winner. Additionally, we're saying that the board is going to be a list of strings. And one of the things that you get from this is, from named tuples, is that you can set a default value. So here I'm using equals to list. So here when I instantiate a state object from scratch, it has a default board, which is a list of strings of the 9 dots. And so without saying anything at all, I have instantiated an object that has the proper data type with a default value. So I think this is just incredibly useful. So when we start a new game, the default state of the board is an empty board, all dots. The default player is X. We're not quitting. This is not a draw. There is no error, and there is no winner. So the optional value says that this slot can either be a string or the value none. And so we're starting off with the value none. And here you can see I'm using a native type called bool. So quit is a Boolean value, can only be true or false, and it's going to start off with false. So this is just an incredibly useful way to describe a rather complex data structure that has types, annotations, and has all these default values. And you get all this by using the named tuple. Later I'm going to show you a typed dictionary, and it's pretty similar and it's very, very cool, but you can't set the defaults in a typed dictionary. So I think that there are many advantages to the named tuple, and this right here I think is really an amazing thing to learn, and I have found that this kind of a data structure serves me extremely well in lots of different ways that I use in programming. So let me just show you here again. If I instantiate this at the beginning of the game, I just say I want a new state object. I see that the board and the player are set to the right values already because I have those as the defaults. And if I wanted, I can override any one of those values by specifying. So if I wanted to start off with players equal to O, I can do that. And you see here that the board is still the default value, but the player has been set to O, which is as it should be. And we get an exception here if we were to misspell a field. That's one of the things that you have going for you when you're using this kind of a data structure. Let's talk in the next video about how we can use MyPy to our advantage.